Hey guys, this week we're in the mountains of western North Carolina because we have reports of a river monster killing all the fish. It's known to live in rivers near agricultural lands and swim downstream to reservoirs where it's got the smaller fish to eat. The locals call it the green killer. Let's see if we can catch it. Guys, we've been out here for hours fishing and we haven't caught a fish or even seen one. But after taking a closer look, we found something. Check it out. We found some filamentous green algae. This may not look like a river monster or have big scary teeth, but this stuff can consume dissolved oxygen in the lake, which fish use to breathe. Guys, the green killer is not a fish, it's algae. There's a lot of tributaries flowing into this lake, so we're gonna have to head back to the office so we can track this killer.
Man's interference with his environment is causing critical changes in our valuable water resources. One major pollution problem is the increase in dissolved nutrients such as phosphorus, nitrogen, and carbon. This increase in the amount of nutrient in a lake is called eutrophication. Consequently, species of fish with higher oxygen requirements are unable to survive.
Since nitrogen and phosphorus are essential nutrients for algal growth, predicting these concentrations in streams can help isolate tributaries causing downstream eutrophication problems. Thus, managers can then implement practices to improve the water quality of impaired water bodies. Popular prediction models use stream flow and seasonality as predictors. These models work well with large observation data sets. However, larger watersheds across the Southeast, like in North Carolina, lack continuous observations over a long period. And as climate changes, so will the water quality dynamics of watersheds. So we need to use a more rigorous model for forecasting nutrient concentrations. Mechanistic models use soil, land cover, and climate forcings to build a simulated watershed model. These models generate stream networks, seen in blue, using elevation data. Land cover data helps identify streams adjacent to agricultural and livestock purpose lands. For culturally influenced watersheds, wastewater treatment plants can also be incorporated. These models can be used to inform water managers on a monthly basis to track the nutrient loads coming into lakes and reservoirs. Using forecasted precipitation and temperature from global circulation models, these models can create a more dynamic management practice to assure healthy water bodies in the future. So people, please be mindful of the fertilizer that you apply to your lands and the things that you discharge into your rivers because they could affect the water quality downstream. And don't forget, fish on.